Hi, I'm going to make a video for Chapter 6, the practice problems, to help you to understand what's going on more. All right, so let's get started. So the first question asks, the patient recovery time for a particular surgical procedure is normally distributed with a mean of 5.7 days and a standard deviation of 2.1 days. What's the median recovery time? So remember, when we're talking about normal distribution, we're talking about the mean equals the median because of that bell-shaped curve. So what I'm thinking of is, when I look at it, is in the very middle is the mean, and 50% of the data is on the left of the mean, and 50% of the data is on the right of the mean. Well, if you go back to Chapter 2 and you think about the median and what that means, the median is the middle 50% of the data. So we know when it's normally distributed that the mean equals the median. So the answer for this one is 5.7. So here's another one. The patient recovery time for a particular surgical procedure is normally distributed with a mean of 7.9 days and a standard deviation of 3.3. What is the z-score for a patient who takes 13 days to recover? So I'm going to go ahead and get out my calculator. Oops, not that one. Sorry about that. We're going to bring this one up, and I'm going to turn it on. So what I need to do is I need to go ahead and take my data value, which is 13, subtract it from 7.9, close it, and then divide by the standard deviation. That's the z-score formula. And if you go look in the notes, the PowerPoints, and the videos, that's what it is. So again, I've got data value minus the mean divided by the standard deviation. The reason I put these brackets is if I don't, with the order of operations, it's going to do it all the way through, and I'm not going to get the correct answer. So if I hit enter, I get 1.5454. So I'm going to round up and do 1.55. All right, let's go on to the next one. And this is a three-parter, so let's talk about this one. In 2005, excuse me, let me bring this up on my other screen too, just so I can give you what we're doing. All right, in 2005, 1,475,623 students headed to college to take the SAT. The distribution of scores in the math section of the SAT follow a normal distribution with a mean of 520 and a standard deviation of 515. Calculate the z-score of the SAT score of 740. All right, so let's go back to the calculator and let's go ahead and bring this in. Oops. Okay, so the first thing I'm going to do, I need to get the z-score. So I'm going to do 740 minus, my mean was 520. I'll close it, and then I'm going to divide by my standard deviation of 115. Again, here's my data value, there's my mean, and there's my standard deviation. So if I hit enter, I get 1.91. So what does that mean? That means that the exam score of 740 is 1.91 standard deviations above the mean. Why is it above the mean? It's because it's a positive z-score. If it was a negative z-score, it would be below the mean. All right, so let's go on to the next one. What math score is 1.5 standard deviations above the mean? All right, well, that one's a little bit trickier. So what I'm doing now is I'm given the 1.5 and I have to solve the actual SAT score. So you got to think about how you would do this one, because it's kind of different than anything else we've been doing, because we're having to solve it backwards. So let's think about what we want to do. All right, so the first thing I want to do is I want to do 1.5 times 115. Why am I doing that? Because I want to get rid of the standard deviation that is on the bottom of the other side, okay? And then for that one, what I want to do is I want to go ahead and add the 520 to it. And what I get is 692, okay? So this, what does it want? Is it wants it in one decimal place? So This is 692.5, okay? And because it's a positive z-score, it's above the mean, okay? If you didn't understand what I did, let's go back and look at the calculator. So the first thing I did is I took the 1.5 and I multiplied by the standard deviation, because this whole thing is, think about the previous one, we divide by the standard deviation. And then I added the 520 to it to get the score. You might want to write that one out on a piece of paper to see how I worked it. I basically solved for x, where x was the data value. All right, so let's do this last one. For 2012, the SAT math test had a mean of 514 and a standard deviation of 117. The ACT math is an alternative to the SAT and is approximately normally distributed with a mean of 21 and a standard deviation of 5.3. So if one person took the SAT and scored a 700 and a second person took the ACT math and scored 31, who did better? All right, well, that's kind of a crazy one. So let's do this based on z-scores, okay? So the first one we're going to do, I'm going to clear this out. Let's do the SAT. So I know the SAT, the person got a 700. Oops. Minus, and there's the mean, 514. I'm going to close it, and then I'm going to divide by 117. All right, so I put that in there, and I hit enter. So my z-score for that one, I'm going to give it 2 decimal places, so it's 1.59. So I'm going to put 1.59 here. All right, so let's do it for the ACT. So that one is going to be 31 minus, what was my mean for that one? 21. Okay, 21. And then divide by 5.3. 5.3. Hit enter. And then I get 1.86. So that's going to be 1.89. Okay. So who did better? Well, let's look at those two z-scores. So remember, as your z-scores keep going up higher and higher, that means the person did better percentage-wise. Because when you go from the left to the right, you're going from 0% all the way up to 100. So the person who took the ACT, because the person had a higher z-score, and that's what that means. Because they had that higher z-score, they did better, okay? All right, so let's go to the next one. All right, this is where we start using the actual normal CDF and inverse norm function that you'll see in the videos. So let's do this one. So a patient's recovery time for a particular surgical procedure is normally distributed with a mean of 5.9 and a standard deviation of 1.7. What is the probability of spending more than 2 days in recovery? All right, I've made a sheet to help you with these and what to put in the scenarios. You really need to look at that study guide and watch the videos for the lectures to understand it. But I'm going to show you quickly how to do this one. So I'm going to go to, hold on. I'm going to go to second VARS, and I'm going to go down to normal CDF. So let me show you again. Second VARS, normal CDF, and I hit enter. Okay, so for my calculator, yours might be a little bit different, and it's going to say lower, upper, mean, and standard deviation. Again, watch the videos I made. They can walk you through it. Again, this calculator is kind of different, so I'm going to put it in this way. So the first thing I want to do is, because it says more than 2 days, I want to do 2, comma, and then I'm going to do infinity. So I'm going to do 1 second, comma, oops, I didn't do it. Let me do this again. Let me go second VARS, go here, and again, I'm going to do 2, comma, and I'm going to do 1 second, comma, 99. And that means positive infinity or positive 1 with 99 zeros behind it, okay? And the reason I'm doing the 2 as my lowest number is because of this word more in here. And again, if you don't understand this, I have a guide that can help you. I even have the pictures where I draw the graphs and explain each scenario. The next thing I want to put is my mean. Oops. 5.9, and then another comma, and then put my standard deviation, which is 1.7. Okay. I put that all in my calculator. I close this and I hit enter. And then that is the probability I get. So it's going to be 0.9891 because it wants it in 4 decimal places. So the probability of spending more than 2 days in recovery is 0.9891. Okay, so let's do the next one. All right, so this next one is a little bit different. This one talks about this. It's got a different one. It's the patient recovery time for a particular surgical procedure is normally distributed with a mean of 5.8 days and a standard deviation of 2.1. What is the 70th percentile? Okay. So we're going to go back to second VARS, but this time we're going to go down to inverse norm. Why am I going to inverse norm? I'm going to inverse norm because it brought up that percentile. And what is the 70th percentile? And it wants the answers in days. That's different than what it asked up there of probability. So I'm going to convert the 70th percentile to a decimal, 7.0. Then I'm going to put my mean. Then I'm going to put my standard deviation, which is 2.1 days. Okay. Close that up, and then I get 6.90 is the days. So that is how many days are represented at the 70th percentile. Okay. And here's another one very, very similar to that. So let's look at this one. The length of time it takes to find a parking space at 9 a.m. follows a normal distribution with a mean of 6 minutes and a standard deviation of 3. 70% of the time it will take more than how many minutes to find a parking space? So how would you do that one? You've got to think of that one in terms of 70th percentile and what it's talking about. So what you want to do, okay, let me go ahead and bring this up. Okay. 70 percentile of the time, it'll take how many more minutes? All right. The thing is, it's saying how many more minutes to find a parking space. So what I'm going to do is I'm going to do 100 minus 70 gives me 30. So for this one, then it's going to be inverse norm 0.30, comma, because I want to know 70% of the time it takes how many more parking spaces. So I want the upper 70% of this data. I do that. I do my mean of 6 minutes, and then I do my standard deviation of 3. I close it, and I get 4.426. So this one is going to, or 423. So let's do 4.43. That's how many minutes. And why did I do that 30 right there in my inverse norm? Because it takes more than how many minutes. It wanted the greater than scenario for this. That's why I did this. I hope this has helped. Again, you need to watch the lecture videos, look at the guides I made, and actually practice the homework to understand these. But once they click, it'll be a lot easier. Thanks.